I'm James. I'm here to talk about the Bluetooth protocol stacks, radio layer, and data link layer. So the Bluetooth standard has many protocols that are grouped into loose layers. The bottommost layer is the physical radio layer, which deals with radio transmissions and modulations. The link control layer deals with master controls time slots and how the slots are grouped into frames. The link manager handles the establishment of logical channels between the devices. The L2 cap that frames variable length messages and provides reliability if needed. The upper layer is where applications are located. Now the radio layer. Now the radio layer moves bits between the master device and the slave device and vice versa. Low power system, the radio link layer has a low range of 10 meters and operates in the same 2.4 gigahertz as 802.11. And to coexist, these two had to use a method called frequency hopping to reduce the interference between the two. Now, an early version of Bluetooth and 802.11, they interfered with each other enough to ruin their transmissions. So to address this, Bluetooth had to adapt their hop sequence to exclude all channels where there are other RF signals. And this reduces harmful interference. It's called adaptive frequency hopping. Now the link layer turns raw bit streams into frames to send over the data. The link manager sets up logical channels called links to carry frames between two devices who have discovered each other. Now the old method of pairing for Bluetooth devices had the user configure both devices with their own user-made pin numbers. But because of the fact that it was user-made, users were lazy, which ended up making for bad security. So instead, they had a new secure, simple pairing method, which had users confirm that both devices had the same PIN numbers. And this was more secure because it auto-generated the PIN numbers rather than having the users manually set it up. Now, two main links exist to carry user data. The first is synchronous connection-oriented, and it is used for real-time data such as telephone connections. Due to the time-critical nature of these SCO links, frames that are sent over them are never retransmitted. Forward error corrections can be used to increase this reliability, however. The other kind of link is asynchronous connectionless link, and this is used for packet switch data that is available at irregular intervals. Frames can be lost and they can be retransmitted if they need to. Then the question is, what are the two main links that exist in the link layer to carry out data?